So in our Explore today, we had you guys find the values for this. So that was a big part of our class. And now we're going to talk about how to actually write our solutions now that we have them. So the solutions for this that we found in class were, and again, I'm just going to abbreviate, but if we wanted to be thorough, we should say the real numbers. There are such thing as imaginary numbers, but from here on out, I'm just going to say real numbers Rn, just for sake of simplicity and keeping this video short. But the real numbers, and there's two of them, 5 or -5. Those make this a true statement. The set notation we always use brackets to denote solution sets, and we're just going to list them. Anytime that you can list them, we're just going to list them. And then we can also, if you remember graphing them on a number line, it's always good to make sure that we graph, we denote the variable that we're graphing. We're graphing the variable A, and give some form of reference. So I know 0 is a good place to include on a graph, and I'm going to just include -5 and 5. And to denote that we want those solutions, we're just going to put a point over the top of -5 and 5. That indicates that nothing else on that number line solves that equation. And that's the basics. And we're going to look at different situations, and that was a big component of today's class, was different scenarios that can come up. Now in this one, something squared is -25. That's nothing. No real solutions is the full description of that. There's no real number that solves that equation. The set notation, since no number is in the set, 2 brackets is fine, or a really popular symbol for that is a circle with a slash through it. And the number line is even easier. We graph that. The A is our variable, and there are no solutions. So I'm finished. I usually like to include at least a couple of numbers just to give the person looking at it a sense of where we are. So there's our second case, no solutions or no real solutions. Another case that can come up is we just have a singular answer. And same thing, we have to at least specify, I'm going to just say real numbers, just for abbreviation purposes, equal to, and in this case it's 5. So it's just the number 5. The set notation is just the number 5, and the graph is just the number 5. So the value is P, here's 0, here's 5, here is my solution. So we're just representing our solutions in different ways. And the final couple solutions that come up, iMuffs, that we came up for this one was, if you look at this is always a true statement no matter what the variable for x is. So in this case, it's going to be all real numbers. And there's a really neat symbol for that, is just a capital R with kind of 2 vertical bars. That's our set notation, just like how the empty set had its own symbol. The set of all real numbers has its own symbol, so we're just going to do it that way. And same thing on the graph. We have to indicate that any number solves this. So I'm just going to get a little reference here, and all real numbers, you can just make a dark line over the top of it, and with 2 arrows indicating that every single number solves this equation. There's a lightning bolt. I don't know why. And, sorry, I got to clean my slides better. This one, so again, another one where it does appear that x over x has all solutions, but we said that this one was all real numbers, except there's one value that doesn't work, and that's 0. So 0 does not solve that. 0 over 0 is actually undefined. So the set notation, now this gets a little interesting. So we have to say that x is real, because now that we have lots of answers, we can say it this way: x is real. We just put this vertical bar here to say that we're going to add more information to this set. So x is real, and then we're also going to say that x does not equal 0. So that's a nice quick way to denote that. So all the real numbers except 0 is what that says. And the graph, here's 0, here's 1, here's -1, and we have to kind of mark the opposite. We have to mark that everything except 0 is the solution. So how we indicate that is we actually leave an open circle over the top of it. So that indicates I don't actually want a point there, but everything up to it I do want a value. So essentially this boils down to all real numbers except for we're just going to leave a gap at 0, because that's not a solution to this equation. And those are a lot of the different scenarios that can come up. We got one more. Awesome. So the last one, and this is we talked about this one in class. We subtracted 2. We found out that anything bigger than 2 was a solution. So how do we write that? So in words, we can say all. I'm just going to go R and N for real numbers. Greater than 2, and that's the verbal statement that solves this. That expresses these solutions. But the set notation, same thing. We can say W is real, so they do have to be real numbers. And then we indicate that W is greater than 2. And we can go that route. And the graph, again, I'm going to graph W, so there's my graph. Here's 0. I'm going to use 2 and negative 2 for this. And I want all the values above 2. So I don't want 2, so I indicate that, remember, with an open circle. And where are the values that are above 2? Well, that's to the right on the number line. So I'm just going to shade that to the right. And those are some different scenarios that can come up. Again, there can be greater, it can be less, it can be not equal to, it can be all real numbers, it can be nothing, it can be a singular number. Those are all the scenarios that can come up in graphing.